Assalamu alaikum wa rahmatullahi wa barakatuh. We will continue studying our lessons of limits or of evaluating limits. As we covered finding limits graphically and numerically, today we are going to talk about evaluating limits analytically or algebraically, and especially for the function of rational or rational functions. Just to remind you that the rational function is a function that can be written as a division of two other functions like q1 of x, or two polynomials, q1 of x function here and function down function like q2 of x. So that's called rational function, and you will see how we can evaluate such functions. Now let's go back to remind you about how to evaluate a function algebraically. And if you remember that if I want to find the limit when x goes to a value, we need only to try to substitute, direct substitution, to replace the given value x in the function. So we call it direct substitution. We need only to substitute or plug in the x value into function, and the result will give me the limit. And look at these examples. If I want to find the limit when x goes to 1 here, so I need only to replace 1. So it will be 1 to the power 3 plus 2 multiplied by 1 minus 5. So directly I will get the result, which is -2. That means the limit exists and equals -2. So we don't need to search for analytically or numerically or graphically. Let us take this example. Also, we will replace 9, so it will be 9 squared minus 9 over 9 minus 3. So directly I get, so I replace 9, so I get 12. And same as for this equation, I just replace -27. So the cubic root of -27, we know it is -3. So this will give me a hint that if I have a function or a limit and I need to find its value, I just replace the given number into the function. If I get the result, that's it. This is the limit. But in some cases, we cannot find the result by direct substitution, as we can see here in the following examples. Now, if the substitution in the limit result in 0 over 0, in this case, calculator cannot give me the answer. So I need to search for another way to get the answer. One of the ways, like this example here, when you replace x equals -5, so I got up 0, and I replace in the denominator, I get also 0. So 0 over 0 dividing by 0 is a big problem. We cannot use calculator to get the answer. So in this case, we search for another method, and here there are two methods we can say. The two methods, the first method is called numerically, as we explained before, was to make a table and study the behavior from left and from right, and we see what's the behavior when x goes to -5 from the left, and what's the behavior of the function when x goes to -5 from the right, and if they are equal, the limit exists. But the new method is analytically, is to rewrite the function, the same function we have, in different way. We call it algebraic manipulation. We play with the question, we change the shape of the question by either factoring or rationalizing or finding LCD or many other methods according to the question. Now let us take the main case, which is 0 over 0, and we don't need to talk about numerically. We'll talk only about analytically or algebraic manipulating. There are many algebraic manipulatings. One of them is called factoring method, and the other method is called rationalizing the numerator, or rationalizing in general. Rationalizing, it means multiplying both the top and the bottom by conjugate, or by the conjugate. We will see what's the meaning of the conjugate, but this rationalizing is recommended when we have a square root in the limit, if the limit has a square root. Now let us focus on evaluating limits by factoring. Let us take this example that we just said. When I replace -5, I get 0. When I replace -5 down, also I will get 0. And this cannot be obtained by calculator, so we need to find another way. One of the ways is to do factoring for either the numerator or the denominator, but here the factoring will be done for the denominator. As everybody knows that this one can be factored by x minus 5 and x plus 5. Difference between two cubes. So we need to factor the polynomial by one of the factoring techniques. So after doing the factoring in this way, we will find here there is something in common. We can see here there's x plus 5 here and x plus 5 here. So we can easily cancel the common factor. When I cancel the common factor, I will get a new limit. And this limit, if I replace, the direct substitution will work. So when I replace -5, I get -1/10. This is the first example. Now let's go to study or to solve more examples. The second example we want to solve here, limit when x goes to 4 for the polynomial up, or trinomial here and trinomial here. The first one we need to replace to make sure it is 0/0 or not. When I replace up and down in the numerator and the denominator, I will get 0/0. That means this will give me 0. Replacing here will give me 0, and replacing here also will give me 0. So in this case, I cannot use any direct substitution method, so I need to use factoring. So the factoring here, we can remember easily that we can do factoring by many methods. So one of the factoring techniques, you can use calculator by using mod 5 then 3 as solving the question. So by using calculator, you may get x equals 4 and x equals 1. When I get x equals 4, it means the factor is x minus 4. When I get x equals 1, so that means the factor equals, or the factor is x minus 1. Also here I can use factoring techniques, or I can easily use calculator. So it will be x minus 4 and x plus 2. And clearly there is a common factor, which is 4, x minus 4 and x minus 4. We can cancel them. So we get a new limit. Now I replace, and the direct substitution will work here. So I get the answer 3/6, which is half. More examples about factoring. Here, the numerator has degree 3. So degree 3 here, we need to remember what factoring I have to use here. You need to remember that there is factoring called difference between two cubes, or sum between two cubes. With the difference between two cubes, I need to write small bracket and big one. For the small bracket, I take here only a minus or plus b. Then, which means here x and the cubic root of 1 is 1, so x minus 1. And then the bigger bracket, it is a squared, which means here x squared, minus the same sign, opposite sign. We take the opposite sign here. So it will be, if it is minus, it will be plus. If it is a plus, it will be minus. Then we multiply x by 1, it will be 1x. Then always positive, the 1 squared. The 1 squared. So this is the factoring by difference between two cubes. And down I have x minus 1 as it is. Then what I do, there is a common factor, I can cancel it. So I'll get a new limit. I replace 1, so I get 1 plus 1 plus 1, which is 3. And just I want to remind you again, you need to remember that there is something called difference between two cubes or sum of two cubes. These are the formulas for factoring. Now let us take more examples again. We have 4 minus x squared over 2x squared plus x cubed. We need to do factoring by the way we know, which is difference between two cubes, so difference between two squares. And also here we can take a common factor, which is x squared. Then clearly we have 2 plus x, we can cancel them. And after cancelling them, I get a new limit. Then I replace, then I get the answer. One more example, and here there is a trick here. We need to focus on this trick. When I do factoring, I get here x minus 2, but up I have 2 minus x. I cannot cancel them randomly because these are similar to saying 5 minus 7 divided by 7 minus 5. They have the same value but different sign, because this one it is negative 2 and this one is 2. So I cannot cancel them randomly. I need to cancel them, but I keep what? The minus, or we can say take a minus 1 as a common factor. So when you cancel them, we put minus 1 here. So this is the trick here. So we take minus 1 out so we can cancel. Then the new limit will be minus 1 over x plus 2. And replace, now we get the answer. And the final question is also to do factoring by the way we know. Then we cancel the common factor and we get a new limit, and that's it. So the main idea of evaluating limits by factoring is to remember all factoring techniques. Now let's go to the part 2 of manipulating, which is called rationalizing techniques, which is multiplying by the conjugate. So first, what do you mean by the conjugate? What's the conjugate? The conjugate of two things is the same two things but with different sign in the middle. Like if I have a root of x minus 4, and the conjugate should be root of x plus 4. This conjugate or this method will help us to rationalize, will remove the root of x. So this method is recommended when I have square root in the limit, if the limit has a square root. So it will be very useful. Now let us take this example. I have here clearly root of 7 and the root of something, 7 plus x. So that means, and I don't have factoring, that means the conjugate is useful here. Now I need to multiply up and down by the conjugate. And the conjugate of this one is the same but plus. And also down the same but plus. So I get, by the way, if I replace, I get 0 over 0, which is not useful. So when I replace, or when I multiply by the conjugate, I get this part. So this is the conjugate. Now what I have up. I should multiply up by up and down by down. The down by down it is only x multiplied by this or these terms. So since they are not conjugate to each other, so we keep them as they are. We simplify only the terms with its conjugate. The easy way to multiply, if I don't like to use FOIL or long method of multiplying, I just say the first term squared minus the second term squared. This is the easy way to multiply two terms by its conjugate. So that means the first one is the root of 7 plus x, and the second one is the root of 7, and always minus between them, always minus between them. So this is the multiplication for both terms, and down I keep it as it is. So down I keep it as it is. Now when we see here, there is square and square root, they cancel each other. Square and square root, they cancel each other. So what I get here, I get only 7 plus x without square root, and I get minus 7 also down, up, and the down as it is, there is x multiplied by this 7 plus x plus root of 7. So I can easily say minus 7 and plus 7, they cancel each other, so to get only x here, and down I have also x by something. So clearly now I can cancel the common factor, which is x with x, so I get a new function which is 1 over that one. So let me repeat again, but by showing you the steps in a proper way, which is if I have square root and I cannot do factoring, so the idea is first to replace, then I get 0 over 0, then I multiply by the conjugate. Once I multiply by the conjugate, I will get the square of this one, which is 7 plus x, and the square of root of 7, which is 7. And clearly 7 will go with 7, so the remaining will be only x. Then clearly there is x with x can be cancelled, so I get a new limit, and this new limit, when I replace 0, the direct substitution will work, and I will get 1 over 2 root of 7. One more example to understand this rationalizing. I multiply by the conjugate, and clearly here the conjugate is this one. And we usually need to remember, I don't multiply with the conjugate of x minus 9, no benefit. We need to multiply with the conjugate of only x minus root of x minus 3. These conjugates to each other, so their multiplication will be only root of x squared, only root of x squared minus 3 squared, and the down as it is, we don't change it. That means we will get what? We will get up only x minus 9, and down x minus 9 multiplied by root of x plus 3. So we can clearly see that these can be cancelled. So I get 1 over root of x plus 3, which is 1 over 6. The last example we are going to talk here is solving limits using rationalizing techniques. We have limit when x goes to 0 for this square root minus 1. So we need to multiply by the conjugate, and clearly the conjugate is square root of x plus 1 plus also 1. And as we said, we multiply something by its conjugate, we just square the first term minus square the second term. So we can easily say here we get only x plus 1 and minus the 1 square, which is 1, and the denominator stays as it is without changing, which means we can easily see that the answer becomes x plus 1 minus 1, which is x. Then we cancel x with x, we get new limits, and when we replace we get half. So we have reached to the last idea, or the last thing, which is the conclusion. So the conclusion, now we have reached to the conclusion of the lesson of evaluating limits analytically. To solve any or to find any limit, first we try direct substitution. If the direct substitution gives me a number, or the result is a number, so that's it, we say the limit exists, and the answer is the limit we get. Now in some cases the substitution and the limit gives me number over 0. In this case we don't use manipulating, we use a numerical method, which is making table and see the behavior of the limit from left and right. And if I get usually I get either infinity or minus infinity, or does not exist, we don't get a number. And if I get, after direct substitution, I get 0 over 0. As we just explained, we need to do manipulating, algebraic manipulating, and the first one is factoring and the second one is rationalizing, and there are many other manipulating techniques, but we don't forget also we can use the numerical techniques, but it's better to use analytically, which is rewriting the function in different shape. Thank you for watching, and see you in the next lesson.